Welcome to our third video on the Limiting Reactants mini-series. In this video, we're going to explore how we can use mole-to-mole conversions to essentially determine how much product we're going to form given a fixed amount of two reactants. So once again, we're going to look at our basic chemical reaction equation involving the combination of H2O2 to form water. All right? Now we've introduced in green here the stoichiometric coefficients that balance this chemical reaction equation. And the problem in specific that we're going to look at here is determining how much water we will get if we start off with 3 moles of oxygen and 2.5 moles of H2. So the steps proceeding just as we did in the previous video amount to starting off by writing down how much of each reactant we're given. So we'll start off with oxygen here. Okay? So we're given 3.0 moles of O2. Similarly, we are given 2.5 moles of H2. Now what we want to do is take each one of these quantities and figure out how much product, how much water we can form if we fully react all the oxygen, and figure out how much water we can form if we fully react all that hydrogen. We'll then compare the amount of product that's formed, and then essentially the lower of the two values will determine how much water we will actually see and determine our limiting reactant. So let's go ahead and move forward here. So if we want to convert how much oxygen, 3 moles of oxygen, how much water we can make, we have to carry out a mole-to-mole conversion that takes us from moles of oxygen to moles of our product, water over here. So with our oxygen, right, we've got a stoichiometric coefficient of 1. I'm going to go ahead and draw that in just for illustration purposes here. Right? So we're going to use that stoichiometric coefficient of 1, putting moles of oxygen in the denominator because we want moles of oxygen to cancel out, and we want to end up in moles of H2O. So we're going to do moles H2O. All right. Now, with this conversion factor, we are converting our moles of oxygen, right, to moles of water, and effectively this amounts to multiplying that initial given quantity by 2, which will give us 6.0 moles of O2, H2O rather. Okay. So that just means that if we were to be able to react all 3 moles of oxygen, we would get 6 moles of water. But again, that doesn't mean that's actually what's going to happen. We have to look at the other reactant involved in this chemical reaction equation and essentially carry out the same steps. So in this case, we want to move from moles of H2 into moles of H2O. So now our conversion factor, in the denominator, we want to make sure that we're canceling out moles of H2. The stoichiometric coefficient of H2 is right here. So I'm going to write out 2 moles of H2, again, relying on that stoichiometric coefficient here. And then up in the numerator, we're going to multiply once again by moles of H2O. Now in this case, the stoichiometric coefficients of H2 and water are both the same. They're both 2. So we're effectively multiplying by 1. So it's not going to change that given value. So we're going to come up with a predicted 2.5 moles of H2O that's formed if we are able to react all 2.5 moles of hydrogen. Now, of course, the moles of hydrogen here give rise to a smaller final quantity of water. As a result, we're going to be essentially in a position where this hydrogen is going to be used up as soon as 2.5 moles of water are produced, and then we're going to have some leftover oxygen at the end of the day. So because this value is smaller, right, that tells us that H2, get my color scheme correct here, H2 here is going to be limiting, and the theoretical yield is going to be this 2.5 moles of water. In the next video, we'll basically explore the next problem of starting off with a certain amount of reactants, but given to us in gram quantities. So stay tuned for that one.